This is where we left in last video. Today we will start by rendering a rectangle, or rect in short. A rectangle here contains four main attributes, which is x coordinate, y coordinate. These first two are basically its position, top left position, and width and height, which is of course the size. Now remember, our screen size is 400 by 400, so I'll be using a smaller rectangle, because if the render object is smaller than the screen, then it will be easier to demonstrate. As I mentioned about coordinates, we are familiar with this, where in center we have 0, 0, our center point is 0, 0, this is x-axis, this is positive x, and this is negative. Similarly, this is positive y-axis and this is negative. However, in Pygame it's a little different. Suppose this is our Pygame surface. Our game window is a Pygame surface 2, by the way. 0, 0 is not center, it's the top left of the surface. Here x-axis is same as previous, but y-axis is flipped. Down is plus and up is negative. By the way, by W and H I am presenting surface width and surface height. As we move right, x coordinate value increases, and as we move down, y coordinate value increases. And when we want to render or draw any object on the surface, we will say Python or Pygame, whatever, where the second object's top left will be. Now when we know about coordination system, we can draw our rectangle on screen. But before that we need one more thing, color. Yes, and Pygame uses RGB color system. You probably already know that RGB stands for red, green and blue, where each of this hue has 0 to 255 levels of value. The higher it is, the brighter it is, and the lower it is, the darker it is. Here I am using pure green, so R is 0, green is 255, which is maximum, and blue is also 0. Now we are ready to draw the rectangle on screen. It's pygame.draw.react. Now we need to give on which surface we want to draw the rectangle, in this case game window, then color, and then finally our rectangle. Now if we run this, we can see our rectangle on the 0, 0 position of window. Now let me show you what happens when we change x coordinate or y coordinate values. As we can see, increase in x coordinate value moved it right, and increase in y coordinate value makes the rectangle go down. Now you should write the code and change the values yourself and see what they do. We were using tuple, but Pygame also has a React class, which is pretty similar. We just need to pass the React tuple we were using, and then we can render the Pygame React object instead of the React tuple we are using. But I will not be use Pygame React in this video. I will just use the existing tuple. Wait, but this is tuple we are using, and tuples are immutable. Means once we assign its value, we cannot change it later on code. So instead we will need a list with same values but a list. And now to make a movement animation, we need to change its coordinal value in every frame. So I will start by changing x coordinate value. Say I wrote has 0. I hope you know why I wrote 0. It's because every value of a list has a key, and this key is its index, which is starts by 0. So for our list, which has 4 elements, the keys are 0, 1, 2, and 3. And so 0 indicates the first element, and which is our x coordinate. So I will write here 0 in third brackets. Now I will increase the value in every frame. Now running this should make the react move right, but you can see it seems react is not moving right, but the width is getting higher. Although it didn't touch the width, we increased the x coordinate value, and here's why this is happening. So suppose this is our pygame window or pygame surface, and in first frame we are drawing the react here. In first frame, notice in first frame we draw the react here, and in next frame we increase the x coordinate value a little bit and draw it again here. See, in next frame, in second frame we draw it here, but the color of the first frame, I mean in the previous frame where we built the react, the color is still there, we did not change that. So with every frame it seems like the width is getting bigger, because the previous frame has their effect still on. To fix that, we just need this simple line, screen.fill 000. Here 000 is again RGB black. What this does is it makes sure to erase everything from previous frame and fill the complete surface again with black. Sorry, we need to do this after updating the screen, because here we are doing it just before showing the screen, and if we color the full screen black and then show, then it will of course show black. Now we can see it is working perfectly. Now let's make it move 1 pixel instead of 2, and let's also update the y coordinate value. Now it's moving 1 pixel towards right and 1 pixel towards down in every frame. Now let's comment out this and try updating width and height in every frame. So this is it for today's video. I will drop this code on description, and if you have any questions you can join my Discord server from the description link. I will be happy to answer, and make sure to subscribe, because in next video we will make our first game, ping pong or pong. So till then, bye.